In this video, we're going to talk about the law of sines. In the law of sines, you can use with triangles that have a 90-degree angle or that doesn't have a 90-degree angle. And with the Pythagorean theorem and the trig ratios, those you have to use with right triangles only. So the benefit to using law of sines and later the law of cosines as well, you can use those equations or those formulas for any triangle as long as you have enough information to plug into the formula. The law of sines states that there are three ratios and they're all equivalent to each other. If I take the sine of angle A and I divide that by the length of side A, that's equivalent to sine of angle B divided by the length of side B. And that is also equivalent to if I take the sine of angle C and divide by the length of C. So when you are using the law of sines, you could have three possible solutions. You could have one solution, which means you have one possible triangle. You could have no solution, where the information that is provided cannot possibly form a triangle. And the third possibility is that you have two solutions, meaning you could have two possible triangles with the given information. Option one is usually the typical situation, but there are special cases where you have no solution or two solutions. So in the first two examples, I'm going to do the typical case of where we would have one solution. So in this problem, it gives us some information about a triangle. It tells us that angle alpha is 33 degrees. So I'm going to label that on the triangle. I'm also going to label that over here as well. It tells us that angle beta is 14 degrees. So I'm also going to put that here. And lastly, it tells us side A is a length of 7 units. Now, side A has to be opposite of alpha, so that's going to be on this side here, opposite of alpha. And I'm going to label that over here that we've got that. Now, we can find angle gamma very quickly because I know that all the angles of the triangle should add up to 180. So if I take 180 minus 33 and minus 14, I'll get the gamma is 133 degrees. Okay, so what we have to find is the length of side B and the length of side C. We can't use Pythagorean theorem or any of the trig ratios because this is not a 90-degree triangle. But we can use law of sines. Since we have all the information for the first ratio, sine of angle alpha over side A, I'm going to use that. So I'm going to have sine of alpha, which is 33 degrees, over side A, which is 7. Now I'm looking for C and B. If I set sine of 33 degrees over 7 equal to the second ratio, sine of beta over side B, I'll be able to solve for the side B. So I'm going to use the first and the second ratio to solve for B. So I have sine of beta, which is 14 degrees, over side B. Now, since the law of sines is just one fraction is equal to another fraction, I can just use cross multiplication. And I can say that 7 times sine of 14 degrees, doing it in this direction, I'm going to make like an X, is equal to B times sine of 33 degrees. And then to solve for B, I would just divide both sides by the sine of 33. And then making sure that my calculator is in degree mode, I would put in the calculator 7 times sine of 14 and divide that by sine of 33. And I would get that b, if we round to 2 places, I get that b is 3.11 units. So now I can do the same exact thing that we just did, but now do it with the third fraction so that we can solve for side c. So I would have sine of 33 degrees over 7 is equal to sine of 133 degrees, which is my gamma, or my angle C, all over side C. And then I would cross multiply. So I would have C times sine 33 degrees is equal to 7 sine of 133 degrees. And then to solve for C, I could divide both sides by sine of 33. And put that in the calculator. And I would get the C, if I round to 2 places, I would get the C is 9.40 units. So now we've solved for all the angles and all the sides. Okay, in the second example, same thing. It's given us information about the triangle. It's given us that alpha is 73.7. So I'm going to write that down here, 73.7 degrees. And it's given us that side A is 73, and A is always across from alpha. It's given us that side C is 55. And gamma, that we don't know what that is, we're not given that information, is always across from side C. Gamma is across from side C. Alpha is across from side A. And angle beta, which we don't know what that is either, that's going to be across from side B. So we're looking for angle gamma, angle beta, and side B. Let me write down here the information that we do know. We have side A, which is 73, and we have side C, which is 55. Now, I can't use the same trick that I used in the previous example to find a missing angle, because that only works if you have 2 of the 3 angles, where you can subtract from 180. We don't have enough information to use that shortcut. If we think back, to our law of sines, we have sine of alpha over side A is equal to sine of beta over side B, which is equal to the sine of gamma over side C. If you notice, we have alpha and we have side A, which is this entire ratio, that first ratio. So I'm definitely going to use that to help me solve for either beta, B, or gamma. So let's start writing that down. So I have sine of alpha, which is 73.7, over side A, which is 73. Now I cannot use the second ratio yet, because if you notice, I don't know what beta is and I don't know what B is. So using that middle ratio of sine beta over B would not be productive at this point, because I need to set up an equation that only has one missing variable so I can solve for that variable. So that's going to force me to use the third ratio in this case. So I'm going to use sine of gamma over side C, which we have that information. So now we only have one missing variable, that's the gamma. Okay, so we're going to solve for gamma, and we're going to use cross multiplication. So we have 55 times the sine of 73.7 is equal to 73 times sine of gamma. So to figure out what sine of gamma is, I need to divide both sides by 73. So I have 55 times sine of 73.7, and I'm going to divide by 73. So when I put that in the calculator, I'm going to take 55 times the sine of 73.7, and I'm going to divide that by 73. And I'm going to get the sine of gamma is 0.723140974. Now I have to do inverse sine to figure out what gamma is. So I'm going to take all those digits. Don't round it yet, because if you round too much with your intermediate steps, it's going to throw your answer off. Wait to round at the end and keep all those digits. I'm going to do inverse sine with all of those digits, and I'm going to get that gamma is 46.31 degrees. Okay, so now I know that gamma is 46.31 degrees. Now I can find beta, because now I have two angles. So I can now find beta by subtracting from 180. So I have 180, and I subtract 73.7, and then I subtract 46.31. And that's going to give me my remaining angle beta to be 59.99 degrees. Now we have just B left to solve for. So now I have to use the middle ratio. So I'm going to use the first ratio and the second ratio, the ratio with A in it and the ratio with B. So I'm going to have sine of alpha, which is 73.7, over 73, which is side A, is equal to sine of beta, which is 59.99, and I'm going to divide it by side B. So now I can solve for B. When I cross multiply, I'm going to get that B is equal to 73 times sine of 59.99 divided by sine of 73.7. So I'm going to put that all in the calculator to see what side B is. So when I put that all in the calculator, I'm going to get that side B, if I round to two places, is 65.86. Now side B is a length, not an angle, so make sure for A, B, and C, those are your sides, so those should have units that are length, like inches or feet or something like that. But alpha, beta, and gamma are your angles, so those are going to be in degrees. So this is all your information. Now they don't tell us in the problem what the units are as far as length, so you can just leave those unitless for right now. But in the future, if it tells you that a side is in inches or in feet, you got to make sure that you label that in your final answer. Now we're going to do an example where we would have no solution. So I have a triangle. Alpha is 50 degrees. So always opposite alpha is side A. Beta is 130 degrees. And always opposite beta would be side B. And A is 4. So really, we're looking for side B, side C, and angle gamma. Please keep in mind that this triangle is not drawn to scale. If I was drawing this to scale and to look perfect, that angle beta would be way bigger than what it is right now, because angle beta is bigger than 90 degrees. So it should be, if I drew it accurately, it should be a lot bigger. So just keep that in mind, that I'm just drawing the sketch to help us visualize the problem, but I'm not really drawing it to scale. If you want to be more careful when you're taking your notes, that's perfectly fine, but just so you're aware of that. Okay, so we need to find angle gamma, side B, and side C. We can find angle gamma very quickly by taking 130 and 50 and subtract it from 180. Well, if I do that, that would be 0 degrees. And 0 degrees doesn't make any sense. You have to have some kind of an angle to open up to get a triangle. So because these two angles already add up to 180, you can't possibly have a third angle. So this is an example of no solution. So you can't have a triangle with more than 180 degrees as the sum of all the angles. Okay, in the next example, this is an example where we could have two possible solutions. The author of the question is giving us that angle C is 33 degrees. The author of the question is also giving us that side B is 10 and side C is 6. Capital letters are typically used for angles and lowercase letters are typically used for sides. So if you have angle C and side C, just make sure that they're opposite each other. So side B means this would be angle B because it's opposite side B. And if this is angle A, then this has to be side A. So we're looking for angle A, angle B, and side A. Those are the three things that we're looking for. If I look at my law of sines, if you notice, I have side C and angle C as a complete set of information for one fraction. So I'm going to definitely use that to get started. So I have the sine of 33 degrees over the length of side C, which is 6. Now I need to pick one of the other ratios to set it equal to so that I can solve for something. So if I use the first ratio with the A's in it, I'm missing angle A and side A. So I will have more than one missing variable in that equation. So I can't use the first ratio with the A's. I have to use the second ratio with the B's in it because I would only be missing angle B because I have side B available to me. So I'm going to solve for sine of angle B over side B, which is 10. And because I set it up like that, I only have one missing variable. And I can solve for angle B. So I'm going to cross multiply to solve this for angle B. So I have 10 times sine of 33 degrees is equal to 6 times sine angle B. And then to solve for sine angle B, I'm going to divide both sides by 6. If I wait until the end around and I keep all my digits to try to be as accurate as possible, my sine of B is equal to 0.907731725. And then I'm going to use inverse sine, and I'm going to get that angle B is 65. If I round to two places, 65.19 degrees. Here's where the second triangle comes in. So if we make a list, triangle 1 and triangle 2. If we make a list of angle A, angle B, C, side A, B, and C, and I do the same for both, we're going to have two possibilities, and I'm going to show you why. So we already know that we have B is 10. So I'm going to fill in B is 10. We know that C is 6. We know that angle C is 33 degrees. These are not going to change for both triangles. But here's where the second triangle comes in. If I look at the unit circle and I look for an angle that gives me a y value of 0.9, something that's really close to 1, there are two values on the unit circle that does that. Right here, where I would swing open 65.19 degrees. But there's another place on the circle where I would have a y value of positive 0.9077. That would be right here. So, to figure out what that angle is, I would take 65.19 and subtract that from 180. So angle B could be 65.19 or 180 minus 65.19, which would be 114.81 degrees. So we have one triangle where angle B could be 65.19 degrees, or a different triangle where angle B could be 114.81 degrees. So now we have to solve for both columns for side A and angle A. Well, angle A is easy to find for triangle 1. All the sides have to add up to 180. So I would take 180 minus 33 minus 65.19, and I would get that angle A for triangle 1 is 81.81 degrees. For triangle 2, I would have to take 180 and subtract 33 and subtract 114.81, and that would give me an angle of 32.19 degrees. So I could have two possible triangles depending on if you use angle B is 65 or angle B is 114. So now I have to find side A for both possible triangles. So now we're going to use the angles for each of the different triangles to plug back into the law of sines to find side A now. So if we do triangle 1 first, I'm going to use the sine of 33 degrees over 6 is equal to the sine of 81.81 degrees is over A. Since I'm looking for side A, I have to use angle A, which means I'm using that first ratio and I'm using the ratio with the C's in it. And I'm setting them equal to each other. When I solve that for A, I'm going to get 6 times the sine of 81.81 degrees, and then I divide both sides by sine of 33 degrees, and I put that in my calculator, and I get that side A, if I round to 2 places, is 10.90. So that's for triangle 1 because I used the angle of 81.81 degrees. Now I'm going to do the same thing for triangle 2, but now I'm going to use angle A as 32.19. So I have the sine of 33 degrees over 6 is equal to the sine of 32.19 degree over A. When I cross multiply, when I solve for side A, I'm going to get that side A is 5.87 if I round to 2 places. So there's my 2 possible triangles. So this all stems from the fact that there are 2 possible angles for angle B on the unit circle that will give me a y value of positive 0.90773175. So it really helps to draw your circle to see those 2 places where y value could be almost 1. And then you find those 2 values, or those 2 angles. Now, there are times where that second angle is too big, and if you add up all the angles, it's more than 180. So in that case, you would only still have one triangle, and you just use the one angle B that would give you a possible triangle. When you're using the law of sines to solve for an angle, you always have to make sure that you look for that second possible angle, because that could yield the special case of 2 triangles.